Hello, dear students. Welcome to Teaching Week 6 on Economics and Math in Modern World. We're discussing cost of production today. Previously, in Teaching Week 1 to 5, we were focusing much on demand. Of course, it was interaction of supply and demand, but we were, especially in the last week, focusing on the subjects relating to how to measure the shape of the demand curve, the factors of the demand curve, and the measurement of the demand curve how it looks and shapes up derivatives, right? And elasticities was about that. And we discussed that the measurements decide how to properly react to the issue of revenue maximization. In certain regions, remember when the curve was inelastic, it was proper to increase the selling price. In other instances, when the curve was elastic, it was proper to reduce the selling price for goods. That was about revenue, right? The demand affects the producer's revenue. But the end point of optimal business management is not so much to maximize revenue as to maximize profits. And so that's important because the profits, the way they're determined, is determined by the difference between revenue and costs. By definition, a profit is a difference between revenue and costs, fixed and variable, both of. There are two types of costs, fixed and variable. And as you deduct all this cost from your revenue, you get the profit. The aim of business management is to maximize the profits, not just to maximize revenue. Sometimes, of course, there are two strategies to maximize profits. One way is to maximize revenue. Another way is to minimize the costs. And both strategies will result in a maximum profit. And of course, the strategies can be deployed simultaneously. You maximize your revenue and you reduce your costs. And in both instances, that will help to move the profits up. This motive of profit maximization is the one which also determines the response of producers and market structures. Will the market be populated by small market players? Will the market be populated by big players like oligopolies, monopolies, duopolies, this thing, right? The market structures. We'll discuss it towards the close of macroeconomics instruction this semester. But largely the shape of the market structure, how it's shaped up, is determined by the structure of producers' costs. That's important. And generally we will come to know today that the shape of supply curves on the P and Q plane, remember the P and Q plane, right, demand, supply. We discussed a lot about demand and the law of diminishing marginal utility, that it shapes up the demand curve. Now we are going to discuss about the supply today. And we will learn that the shape of the supply curve, the upward sloping shape of the supply curve is determined by the law of diminishing marginal product or diminishing marginal returns. Different words are used to denote that law, but that's what determines the shape of the supply curve. So there's a law of diminishing marginal utility impacting the shape of the demand curve, and there's another law to be introduced today, the law of diminishing marginal productivity or returns that affects the shape of your supply curve. Two laws underlying each type of the curve, the demand and the supply respectively. That two laws, the law of demand curve, and that you should know is determined by the law of diminishing marginal utility. Diminishing marginal utility. The demand, right? Demand. The law of diminishing marginal utility. Remember the case of bowling, going to bowling versus going to cinema. We discussed that case a lot. And secondly, we have the supply curve, and that shape is determined by the law of diminishing marginal product. Okay, so we're discussing that today, and that's important, very important, because knowing the laws underlying the operations of both demand and supply curve, their shapes, right, we can analyze problems on the P and Q plane, right, P here, Q here, right, knowing the shape of the curves and the laws underlying them, we can be competent enough to make predictions about how the market will react to that interference or that interference, to that disturbance or that disturbance, or also to internal factors like P's and Q's themselves. I think at this point it's also important to build your vocabulary and introduce the idea of distinction between price, value, and costs. The price is it can be a matter of farm preference, or it can be a matter of effect. When we discuss effects in economic life, we are discussing transaction prices. These are the effects of economic life. So you can have selling prices, meaning transaction prices, right? Selling transaction prices. And I should put slash here, right? And this is the economic fact. Depending on the market structure, remember we were discussing the case of the gold market, gold electronic exchange. There we had the bid and ask, right? The bid and ask prices. The bid prices went on the side of demand, right? And the ask prices went on the side of supply. And the market DOM, the electronic market DOM, right? Market is a piece of software that was pretty much reconciling the bids and asks into the final transaction price. The bids and asks, these preferences on the part of those demanding the gold and selling it, the bids and asks, right, are reconciled through the DOM into the actual transaction prices. Well, is a bid and ask an economic fact? I'm not sure, but you can see it in the DOM, right? Remember we saw in the DOM the bid price and the ask price in that video about the electronic gold exchange. So price can be both a preference or a matter of effect. Especially when it's a transaction price, it's a matter of fact. And there's a notion of value now, right? What is value? There's a price, and also economists are fond of using that word value. What is that? Well, since in market economy prices fluctuate, on one day have P1, on another day have P2, the second day price P3, P4. Obviously, the question arises: what moves the prices, right? Why they fluctuate, and around which point do they fluctuate? It's like a pendulum, right? Remember, like in a grandfather's clock, there's a pendulum. That word, right? Pendulum. Pendulum. In a clock. And it swings, right? So this is like a case of prices fluctuating. I think it's a very apt metaphor for that, right? We have a pendulum that goes up and down, up and down, up and down. Every day, or just every second, the position of the pendulum changes. So is the case of the prices. Every day you have a different price, right? But yet there's a point of gravity, right? Point of attraction or point of gravity for all these prices or all these movements. Gravity. And that is this point, right? This point on this axis. You have that point around which the prices actually oscillate up and down, around the point of gravity. So we can just as well say that the value is a point of gravity for the exchange prices. When I ask students maybe what is their understanding of value, many cited the idea of value being that of an intrinsic worth. That's also a legitimate sense of the word, because value is a word of many meanings, actually. Let's admit that value is a word of many meanings, because there's also a case of a value in use. How much good is worth to you personally, right? It's worth the good to you. In that sense, it's like utility. Instead of using that collocation value in use, I think I discussed that matter under the rubric of utility. Diminishing marginal utility refers to utility, right? That sometimes can be measured as value in use. So in that sense, value is also used as a word, but in that sense, it means value in use. How much the good is worth to you personally, to you personally, right? The person. I'm not sure if legal entities qualify being persons, but in legal framework, yes, legal persons are also persons, and so they can have utility and value in use. That's what financial modelists analyze. They analyze value in use, the investment value, so to speak, right? Investment value. So yes, legal entities also qualify. Legal entities have a personality, right? Legal entities have, in that sense. But the way we are discussing on the slides, right, that notion of value is mostly about value in exchange. Of course, value in exchange, just the fact that we are discussing exchange prices, the effects of economic life, the prices of exchange, and they are governed by the value in exchange. Again, for us, the value in exchange is at center of gravity for the observed prices. Daily they change, and there's yet some center of gravity, I assume, and we assume that. And then, yeah, what is the center of gravity for prices? So, well, in our presentation, of course, it's a Marshallian cross. We have a demand curve, P here, Q here, right? A supply curve, and both intersect at some equilibrium point. For us, that point, its coordinate in terms of the p-axis, that PE here, right, is that value is a center of gravity for prices. That's how we perceive it now. Equilibrium point for prices is a value, right? Is a value. These days it's like that, but before Marshall, before those crosses came into being, I told you the crosses, the Marshallian crosses, supply and demand curve intersecting, they came to be popularized around that time, right? Before that, of course, in political economy, they had the idea that the value underlying prices is not governed by the intersection of demand and supply, but it's more like governed by maybe some implicit entities like embodied labor costs in that sense, right? So that the value is based on labor. The labor theory of value also existed before that date and was like actually the accepted one in mainstream instruction. But these days, yes, we say that maybe labor cost is a contributing factor to costs and supply is determined by costs. But of course, for us, remember the analogy of Marshallian scissors, right? The scissors, two blades are cutting. So for us, the equilibrium price, the value is determined by two blades of the scissors, right? The demand and the supply, the two blades in the demand-supply relations, right? As two blades cutting the price and determining it, so to speak. So we are no longer arguing about what determines the equilibrium price, being the value. It's an intersection of demand and supply, and generally just not intersection, the interaction, the mechanisms regulating the interaction of demand and supply. According to the mainstream instruction, it's like that. And finally, the last item we have to discuss is about the costs, right? So we have the distinction between price, value, and now costs. The third item in the triad is a cost. Of course, we are discussing production costs of produced goods, right? Production costs of produced goods. Only goods that are produced have costs, right? In that sense. But in retail, I guess you can sell not just produced goods, you can sell everything. Including existing second-hand goods, right? And so in retail, there's a certain terminology, like I want to introduce to you the word margin, right? So in retailing practice, you have wholesale costs, and to sell goods on top of resale costs, the retailers put on some margins. They're like profits. So there's also this thing, like similarity between margins and profits, right? So generally, just anyway, not just in retail trade, we can just as well say that costs plus profits, right? Costs plus profits is your revenue, equals revenue, right? And your revenue is determined by selling prices, right? By the selling prices, these prices, the actual prices. Your revenues are determined by them as a product of P and Q, if you remember. Again, this is stating the obvious, just stating that relation on the previous slide and restating it, making revenue to be a sum of profit and costs. So now we know the terminology. For us, costs are the production costs. Let's analyze them. crucial to analyzing the cost is that law of diminishing marginal product or returns, and that is a law that was introduced in Napoleonic period, Napoleonic War period Britain, right? Like around that period, 1806, 1807. What happened historically at the time? Britain was at war with France, right? There were a long history of Napoleonic Wars. They lasted quite a while. And at one point of time, British Isles, right? So imagine this is like a case of British Isles. Here you have Ireland. The entire Isles were under naval blockade by Napoleon. Naval blockade, right? Naval. And so there's no way to import grain to Britain. Here's London, right? London is here. I assume it's like that. He's up north. Historically, it was possible to bring some grain from overseas to Britain, but during Napoleonic blockade, what happened? There was no grain being shipped to Britain, right? So there was a problem to feed the population. And historically, only the fertile lands in the south, right, somewhere in the south of England, were cultivated, the most fertile lands, right? They supported the grain agriculture, fertile lands. And when the war erupted, the naval blockade came to pass, right? Then what happened? There was a pressing need to feed the population. So this lands up north, in the north, had to be pressed into service, had to be cultivated. They were called the marginal lands. And of course, on marginal lands, it's hard to grow grain. The yield of grain yield, right? Grain yield will be will be very low. And even on good lands, you cannot increase yield by much. To work this good lands in the south of England, you cannot really increase yield by much. You can put to labor the available surplus labor force that was in plentiful supply. Maybe horses were in plentiful supply, so you were able to apply extra doses of capital and labor, right? Extra doses of capital and labor to land, and yet the result of the application of the extra doses of labor and capital to land was less than impressionable. Let's say, because of that situation, a certain generalization came into being. Blau called it a hasty Ricardian generalization because Ricardo, he lived around the time of Napoleonic Wars, so he established the science of political economy, right? What we call economics now, and that law of diminishing marginal returns is actually due to Ricardo, to David Ricardo. Again, that law was set up with reference to that situation in British agriculture of the day, in the period of British Napoleonic Wars. And what was observed is just to increase yield from land, the greater amount of labor had to be applied. Initially, before the blockade, it was enough just to apply little of labor and capital, and the technology of the day was very primitive one, right? Because for capital, we had just oxen, maybe, right? Oxen and horses, and also the seed bank, seeds. The grain seed was also your working capital, right? The working capital, seeds, oxen, right? Horses, and what then? What else? The plow, right? The plow, of course. The plow was the technology of the day, was your capital of the day, and the labor, well, it was mostly indentured labor, I would say, the indentured labor employed by farmers, right? That was your labor, variable factor. There was enough of labor, enough of capital, not enough land. The land was a factor in fixed supply. In that period, the land was deficient, right? There was only so much land, so much fertile land in the British Islands. In the British Islands, we are discussing England, right, specifically, just so much of land, including the marginal land. So what appeared to be the case is that for every subsequent dose of application of labor and capital to land, being a factor in fixed supply, right? Land is a factor in fixed supply. It's a fixed factor of production. Remember, in teaching week 1, we discussed the factors of production: land, labor, and capital. Here we have all of them being your production Factors, right? Factors of production. The length is in a fixed supply, it's a fixed factor, but the doses of labor and capital, these doses, right? You can apply them to length in increments as much as you want. They are not in short supply, they are in variable supply, variable. They are variable production factors, right? Variable. So you can apply progressively more and more of the variable production factor. We are considering labor and capital jointly, right? As a combination, concatenation applied to length. As we progressively apply more and more of them to length, the yield is getting to be less and less. The result of the application of each subsequent successive dose of labor and capital generates less yield, less grain yield, right? Progressively, as you come to apply more and more of labor and capital, that factor taken jointly, right? Regarded jointly, the yield from each subsequent successive, right, is less, right? And that's a statement of the law of diminishing marginal product. As you progressively apply more and more of the variable production factor to the fixed production factor, the yield on each subsequent application, right, length is reduced. So we're having the case of diminishing yield. And because it's a yield on each successive or subsequent application of the variable factor, it's a marginal yield being diminishing. Marginal meaning for every unit of extra application of land and capital, every additional application, right? The produce from that application, specific to that application, will be less and less. It will be diminishing. So the law of diminishing marginal product or diminishing marginal returns, much the same thing, is postulated as such, right? That it is a universal law. It was believed to be a universal law because agriculture was essential during Napoleonic Wars. It came to be encapsulated into the political economy of the day, and generally later on, after Marshall even, we still refer to such a law in production. It's to be accepted as an explanation for the supply curves. The laws determine the shape of supply curves. Again, the history is that it came into being from the historical situation with agriculture during Napoleonic War Britain, and whether that law is really an absolute law or not an absolute law, I'm not really sure about that, because what happened historically after the British Napoleonic War receded, right, the memory of them receded, the grain price dropped, the blockade was lifted, the price of bread came to be very cheap, right, because during Napoleonic Wars, having to work very marginal lands, right, very marginal lands up north in Britain, pressing them in circulation, resulted in a very high cost of bread because the labor on those lands had to be compensated, so the price of bread shot up to make the production economically feasible, right? The price for bread shot up, and of course there was an idea that on marginal lands there's no rent, but on those lands, the fertile ones down south, landlords were developing in luxury because they were getting huge, tremendous rents on their lands up in the south. It was very easy to cultivate bread, and the price for the bread they cultivated was very high. It was determined by the cost of production on marginal lands. Now, it's called a theory of differential rent. If you're interested in the study of economics, you should come to know about that at one point of time, the theory of differential rent. Due to Ricardo, again, that's an offshoot of the law of diminishing marginal returns. Please read Black. If you're really interested about Ricardo and about the law of diminishing marginal product, that's on your auxiliary reading. If you really care to understand the history of the law, you can read Black just as well. And let's see if that law is actually an absolute law. Like in the case of British Napoleonic Wars, it was just a blip. It just came into being during the wars, an artifact of the wars as such, right? And then the price of bread went down after the blockade was lifted. And the law, well, I mean, there was a paradox. What happened to the law? Because the bread got to be cheaper, much cheaper. After 30 years, it got to be much cheaper. and Britain became much more affluent. At the time, people were just spending on bread during the Napoleonic Wars. But after that, in the 50s, right, in the 60s of the 19th century, the duty of the bread was taken, so Britain was opened up to unhindered free trade. In agriculture, that law didn't assert itself anymore because the conditions were maybe not, the conditions were not conducive to the operations of the law in agriculture, but something happened. The law didn't work like it was supposed to anymore. It's not an absolute law, and with students we also played a game today, right? Not today, I mean the day before, Monday and Tuesday this week, to determine whether that law applies to their production process. And that production process was, well, it was also like a production process of sorts. It was the idea of cutting snowflakes. We had a production process, we had a raw material in the form of A4 sheets of paper, right? We have ladies cutting the snowflakes, and we had a certain endowment of production equipment. We had a table, and we had scissors, and it was assumed that our production factors, the scissors and the table, were in fixed supply. It was such a game that we played. We had just one table and 4 scissors I brought to the class. We had just 4 scissors, and we had to pay rent to make use of the scissors and the table. The chairs were on publicly supply. I gave you as much chairs as you needed, so it was a public provision, the public infrastructure from myself, right? My contribution, the chairs to the game. But then for this you had to pay rent to the scissors and the table. It was a fixed supply factory. We only had that much, no matter how many ladies were working the process, the production process. We had just one table and 4 scissors. The raw material was unlimited. I brought enough paper to the class, except for the last class. I brought enough paper to all of them. And then we had labor costs. The idea was that you were notionally compensated at a certain rate of a salary of $0.50 per person per minute. And then those persons employed in the process, we ran an experiment. First, we employed just one lady, right, to work the snowflake production process. And we measured the productivity of the process with the employment of just one person, right? So for us, these two factors were fixed factors, but then raw material, paper used for the snowflakes, and the labor were the variable factors. We had them in plentiful supply, and we measured productivity at a stretch of 5 minutes. Progressively, 2 people, 3 people, and 4 people were told to cut snowflakes, and I measured productivity. There was a person keeping time, and I recorded the output. So at one point of time, when we employed 2 people, for example, to work the process, it was possible to produce 3.9. Well, just one snowflake was not really complete, so I put 3.9, but actually let's say it's 4 snowflakes, right? In 5 minutes. 4 snowflakes were made in 5 minutes. And when I employed like 3 people, it was 7 snowflakes being completed in 5 minutes. And so the productivity on per minute basis is like that, right? I recorded that productivity, and then we analyzed the results of that game in terms of productivity. Again, I had to make assumptions because we didn't have time to play till the very end, and we didn't have maybe like 7 scissors. But you can imagine what would have happened with 7 people working the production process. That would have been a mayhem because there are only 4 scissors being available, right, for the game, just 4. And with 7 people working for scissors, well, of course, there could have been a division of labor introduced with some people folding the paper and some people cutting, but I would imagine that even with that division of labor, 7 people is way too much to work for scissors. So I would have expected, of course, for the law of the marginal product the diminishing marginal product to assert itself. That's what I would have expected, especially in that range, right, where we didn't run experiments, but you can imagine there would have been a mayhem around the table. Too many people running and being excited about the game, and just for scissors lying on the table. There would have been just treading on each other's feet to complete the production, and that would have adversely impacted our productivity. Maybe it would have been increasing still progressively, but not by much, and even maybe declining. Like in that instance, I assumed the optimal productivity is like maybe for the total one, it's at that point of 4 people employed, but then actually it declines in absolute terms. That's what I assumed because we didn't have time to complete the experiment. And even with our game, you can see for yourself that the low diminishing marginal product applied to the game. We measured the average productivity per worker, right? Dividing the total product by the number of workmen employed. And then we measured the marginal product as a difference in successive products. This only difference is possible because more people are employed. So every additional contribution here, just the increase in the productivity, is due to more people being employed, and the difference in the productivity between the successive case and the previous case, successive and previous, is your marginal product on account of employing one extra person in the game. It's a marginal product, meaning the additional product, okay? Marginal means additional. Like many times, I never failed to emphasize that point that marginal means additional, right? And that additional or marginal product is presented here, indeed, does decline. Well, initially we started to decline, but then it increased because the game went much more briskly when we had 3 people employed. But then when we had 4 people employed, it should have declined and continued declining. And then that situation with people trading on each other's feet would have asserted itself. So yes, we generally, except for that exception, the marginal product, kept declining in the game. Actually, I held 3 games. In one game, there was no exception. Here it was continuous like that. But in that game I'm now showing, we had some exceptions. I guess in reality, of course, we will have exceptions. Initially, you can imagine your marginal product to behave how? With respect to quantity, your marginal product, that one will maybe first increase, right? And then decline. So that can pretty much be the case. First it increases, and then it declines somewhat. So let's see how it happened here. No, I'm not sure. So first it declined. That's not the correct presentation. I think the correct one in our instance that in that game, right? First it's not a cost, it's a product. So you have to be careful what we are drawing. We are drawing the marginal product, not the marginal cost with respect to quantity. So first it declined, then it increased, and then it again declined, and then it should have increased. Right? So, well, our experiment was a little bit messy on that point. Here, I guess it doesn't count because we are discussing the case of negative products. So, yeah, it should generally decline. It should generally decline. According to the law, it should generally decline with some exception in some domains of Q. Again, the experiment here it corroborates where it's green. The process is corroborated. Here it's corroborated. Here it's corroborated. Here there was an exception to the law. There was a jump in productivity because the process went to be much more brisk when 3 people were cooperating. It's kind of a synergy of production that has asserted itself at that point of 3 students enjoying the game. Initially, there was no synergy. People were just not clear about the aim of the game, and then they came to be clear about it. And there was a synergy in the process because the work went to be much more brisk. But generally, that's a law. As you work your fixed production factor with more and more quantity of labor and raw materials, labor and capital, right? The law will assert itself. The marginal product will decline. That's the law, right? You work this fixed factor with a variable application from these factors. The more you apply these factors to the fixed factor, the less will be the product associated with every subsequent dose of labor and capital applied. The total product will still grow, but the additional contribution to the product from every subsequent unit of labor and capital applied will be diminishing. The total product may still grow continuously and monotonously, but the contribution of each factor, variable factor, to that growth will be diminishing. That's a statement of the law. I'm repeating, it's a diminishing situation, right? The marginal thing, the marginal product, not the total product we're analyzing. The law is about the marginal product, and again, the game was played in which period? Remember, there are 3 periods of market operation. The three periods of market operation are due to Alfred Marshall, who in his textbook emphasized that we have a very short-term period, very short-term, short-term, and long-term. That's a supply-side distinction, right? Supply-side distinction, not a demand side, even though for demand side there's also a distinction between long-term and short-term due to elasticities taking time to evolve, to unfold, right? But the distinction, that one is due to supply side just mostly. So in the short term, in the very short term rather, all the production factors are in fixed supply, nothing can be changed. Obviously, our game was not played in short term, was not played because for us, the quantity of labor employed was not fixed, it was a variable, at least up to here it was variable. We were able to play the game with variable quantities of labor employed. And raw materials were also available in not in short supply, so we had two factors variable, and because we had two of them being variable, our game wasn't played in a very short term. We were able to change the production and supply of the snowflakes with the application of more variable factors. Our game was actually played in a short term, not in a very short term period, but a short term period, because some factors were fixed and some were variable. And we were experimenting about the effect of variable factors on the fixed endowment. And the experiment more or less corroborated the low diminishing marginal product, the low diminishing marginal returns, right, with respect to the application of these variable factors to the fixed factors of production. This generated progressively less and less of returns when applied and when worked on the fixed production factors. Our game was played in a short-term period because we had variable factors working the fixed factors. Our game was not played in the long term precisely because in the long term it's assumed that all the factors can vary, including you can have more scissors and more tables in the game, right? More scissors in the game. That was not the case in our game because by the terms of the game that was always fixed. When it's variable, the game would have been played in a long-term period, but it would have been some other different game. Our game was a game of a short-term period in terms of supply side. Okay, so this is one specification of the game we played. Then what we did, we established that the total product declines, more or less roughly, or more or less smoothly, with exceptions, right? Then we decided to analyze the product of the game in terms of the costs, right? How much did it cost us to produce the snowflakes using these inputs? The fixed costs, the rent for equipment for fixed factors of production, that was like $4. Okay, for scissors used, rented at $2 per minute each. One table was rented for $10 per minute. Again, the snowflake raw material A4 sheet of paper was costing us $1 per snowflake, and the salary was half a dollar per person per minute. So our variable factors were compensated according to that scale, right? And our fixed ones were fixed, and still the rent had to be paid on them. Then we discussed, I'm transcribing in the table for analysis in money terms my total product from that column from the table. It's transcribed here. I do something to analyze, I guess, to analyze revenues, but it's beside the point because we are focusing on costs right away. What about the costs, right? We distinguish between the total costs and average costs. Very important distinction. And the last type of a cost we are also analyzing is that type of a cost, the marginal cost. So there's three types of costs generally, right? Just three types: total costs, average costs, and marginal costs, right? There are three types of total costs, three types of average costs, because averages correspond to the total, right? If there are three types of total cost we're analyzing, by implication, there will be three types of average cost we will be analyzing. But there will only one type of a marginal cost, not three, but just one. And you will see shortly why. Anyways, let's start analyzing the costs of the game. Total fixed costs. They're called fixed because no matter how flexible you are with the employment of the variable production factors, the fixed costs are fixed, and so the rent on them is just same amount no matter how many doses of labor I'm employed. The fixed cost is always the same, $18, because it's $8 for scissors and $10 for the table, right? So it's just in total $18 for the entire domain of the quantity of labor being brought to bear on the game. Just the same amount for the total costs. What about the variable costs in the process? Variable costs are called variable costs because they vary with the amount of variable production resources employed. The more you produce, in other words, the greater will be your cost. It will not be a fixed amount anymore, it will be a variable amount because, for example, each and every snowflake embodies one sheet of A4 paper. The more snowflakes you make, the more will be the expenditure of the A4 sheet of paper, right, on the production process. You'll have to spend more paper according to the ratio of one A4 sheet of paper, right, one sheet for one snowflake. So the more snowflakes you make, the more sheets of A4 paper will you expend on the production process. Therefore, the cost of that paper is a variable cost. It depends on the volume of production for the snowflakes. It's a variable cost. And so is the labor, because to make more snowflakes, you need to employ more labor. Anyways, it's like that always. So the more you produce, the more labor you will employ, and the more it will cost you to employ that labor, because every person is entitled to the rate of compensation, $0.50 per person per minute in our game. So the variable costs, they depend on the volume of production. Unlike the fixed costs, they don't have that dependency. They are just fixed all across. But the variables are changing, right? And the total cost, by the way, how is it I'm estimating here in the game the total variable costs? So in our game, we know how many workers are employed every step of the way. Let's say three workers are employed at this junction in the game. So I multiply the quantity of labor, right? The number of workers employed. Where is that? The C23, right? That number by the salary of the individual worker per minute. I will get something. Obviously, if you multiply 3 by 0.5, you'll get 1.5, and that will be the labor cost. Plus, there will be something on top of the labor cost that will be the variable cost of raw materials. And when you employ 3 people, you make how many snowflakes? 1.4 snowflakes in a minute, right? And each snowflake is costing you, in terms of the paper it consumes, so it's $1 per snowflake, and you make 1.4 snowflakes per minute. So it will cost you $1.4 per minute in raw material costs to make that snowflake. So it's $1.5 in terms of labor and $1.4 in terms of the raw material costs to make the snowflake, right? So those two terms are your variable costs for that situation with 3 workers employed. It should be 2.9, right? It's $1. It's not $0.5. Here it says 1 for some reason. If you put 0.5, I was experimenting and maybe I just changed the numbers. Okay, then it's 2.9 as I said. Okay. 1.5 on account of labor, variable labor costs, plus the raw material cost to make 1.4 snowflakes with 3 workers working. Remember, all these parameters, the total product, the costs, all of them, are the flow variables, because the flow variables are measured in dollars per period. And in our analysis, the period is per minute. The product is measured on per minute basis, the rent is measured on per minute basis, the salary on per minute basis, the cost should be therefore measured on the per minute basis. And the raw materials are tied to the number of snowflakes produced, so we have to recalculate according to the product on the per minute basis, right? The total costs are easy. Now the third type of the total cost is the sum of the fixed and variable cost, right? So FC plus TVC, total fixed cost plus total variable cost, will give you the total cost, meaning the total cost, just everything included, right, to produce snowflakes per minute on the basis of the production process organized with 4 workers. In that instance, when you have 4 workers, your total cost per minute will be $21.5, right? 18 of them being your fixed cost, right, and 3.5 being your variable cost. Okay, so now we are done with total cost analysis. What is the average fixed cost? When you want to estimate averages based on the totals, so it's very easy to convert. So you want to estimate some average cost. You take the respective type of the total cost. We have 3 types of the total cost. So for every total cost, you can estimate its respective average. So you take the total cost and divide by quantity of goods produced at this total cost. Total cost for the goods divided by the number of goods produced, and because again a flow variable is involved here, a flow variable, it's an average cost per minute. We are discussing flow variables. Total cost divided by quantity, right? It gives you the idea of the average cost. It's meaningful, to analyze average costs and to try to produce such as to minimize your average costs. We'll see about that shortly. And so according to the rule, and that's just a basic definition of the average, you divide something, the total, by the quantity to get the average, right? Amount of something. Total fixed costs are like that, fixed, but if I divide by quantity, of course, here they were fixed, but now they're declining. Here they were fixed, now the average of the total fixed cost is declining because you are spreading out. What we are doing effectively, we are spreading out same costs over greater amount of output produced. You are dividing by the amount of output which is getting high, more and more every step of the way here. Then as you divide, right, of course the costs are reduced. The average costs are less, they get less and less. If the average, the shape here for the costs in terms of Q and here we have costs, right? Costs, and here we have the quantity, right? For the fixed cost specifically, the fixed costs, the total fixed costs, right, will be just a flat line, but the average fixed costs, average fixed costs will be the declining line. So it's total fixed cost, and that will be the average fixed cost. They're spread out over greater output, they're spread out over the whole extent of Q, and so the averages are reduced. The totals stay the same as a flat line for totals and reduced one for average fixed costs. Again, if we run same analysis on our average variable costs, all you have got to do is to divide total variable cost by the quantity. Total variable cost by the quantity. Every step of the way you can just drag it down with the mouse to get these numbers. In our instance, well, as a mixed, it's a little bit mixed. First they increase, then they decline, then increase again, increase again. They look like to be increasing mostly. Our averages they tend to increase with some exception here. And the average total cost, again, you take the total cost and divide by the quantity, right? Total cost divided by the quantity, and you get some number declining, right? The total costs here, because the fixed costs are declining materially, the average fixed costs are declining materially with extra output. Our totals are also, of course, declining. Our average total costs, to be specific, right, these ones are declining. Uniformly, are they declining uniformly? No, they jump up a little bit here, but for the rest of it, yes, it's a uniform decline. So we know about total costs, we know now about the average costs. What about the marginal costs? The marginal costs are the costs to make additional unit of output. Every step of the experiment, we make greater amount of product, so that additional product is costing something to make. And the cost of that additional product, the cost of the first product, the second product, the third product, that cost specific to that product is called the marginal cost. And generally, in terms of mass, we can say that with respect to quantity, right, our marginal product can be defined as the difference in total costs associated with the increase in production, right? We increase production, so our costs of production increase. By how much we increase our production in some experiment? By delta Q, right? And because of that greater production, there will be higher total costs, right? High total costs. And that increase in the total cost associated with one extra unit produced is a marginal cost. So the marginal cost by definition is that thing. Increase in total costs in connection with the extra unit of goods produced. The total costs are increasing because you produce something extra. By how much they will increase if you increase your output by 1 unit of production extra? Yeah, that's answered by the value of the marginal costs. Again, the marginal cost is a derivative. If you know about derivatives by now, of course, you know the marginal cost is a derivative of the total cost function, right? If the total cost function is continuous, you can also just differentiate it, right? By dq. D total cost by dq is a marginal cost if it's continuous. If it's not continuous and you only know like according to certain increments here in terms of your production increases, then you have to take the ratio. It will be the interval ratio, right? But if it's a continuous production function, production cost function, then you can just as well take a derivative, right? In our instance, I guess it's not really a continuous experiment because we only have this ranges, these intervals, not a continuous, nothing in between these numbers that we can tell differently about the production process. Our process is not a smooth one. We stage the experiment in stages. At that stage, we have that output, that and that output, and nothing in between. So we cannot really differentiate the production function, but we can take the differences and estimate the marginal costs for the specific intervals as your production quantity of labor increases, right? And that's what I'm doing here. I take two neighboring cases of the experiment, estimate the increase in total costs in the numerator, and in the denominator, I divide the increase in total costs that increase by the shaded increase in the product, dq. And my dq is that product, right? Per minute. Again, flow variables are analyzing, so it's per minute basis everywhere. Per minute basis for cost and the quantity. It's all per minute basis, that and that, right? Divide increase in total cost by the increase in quantity. And you will get a ratio by definition is your marginal cost. You may ask why we have three types of total costs, three types of average costs, and just one type of a marginal cost. How come? Well, the answer is that for total costs to change, the total cost being the sum of the fixed costs and the variable, right? Then just notice the fact that the variable costs are the ones changing. The fixed ones, they don't change. They cannot change. So the only reason the total cost changes is because the total variable costs are also increasing, right? Fixed are the same ones, total variable costs changing, so therefore the total costs are also changing. So the marginal costs, they only change because the total variable costs change, using the change in the total costs. So the notion of let's say marginal fixed costs is a nonsense, right? It cannot be such a thing. They don't change, so they're always zero, right? Marginal fixed costs are always zero because they don't change, right? There is extra output, nothing happens to the cost. The extra cost is zero every step of the way. So this is a nonsense notion. There cannot be such a thing as a marginal fixed cost. There can be such a thing as a marginal variable cost, okay, and because the total cost change on account of the change in the total variable costs, we can just as well say that marginal variable costs are same as the marginal total costs, right? And so because they're same, right? Because they're same, there's just one metric for the marginal costs, just the marginal costs, right? We don't care whether they increase because it's like analyzing the total cost or total variable cost. The increases here and here the same, right? So we have just marginal costs, one type of marginal costs out there because extra total costs change precisely because total variable costs change. This changes, this changes, this changes same in both 0.9, for example, here, 0.9 here, 1.1 here, 1.1 here, right? You see, the change is same. So this is same, this is same, and so because the two are same, we just can call them the marginal cost change. That's the marginal cost, just one type. Whether you analyze them on the basis of that data or that data, you'll get the same result. So there's only one type of marginal costs, the marginal costs, right? Without specification, whether we are discussing variable costs or the total costs, the difference in these two, I mean, the number will be the same. So I guess that's just why there's just one type of marginal costs. And another restatement of the law of diminishing marginal returns. That's an important thing now. Okay, the law holds when the total product declines. Yes to the question whether it declines, but also the law holds when the marginal costs are increasing. Whenever every step of the way the marginal costs are increasing, the law of diminishing marginal product is also asserting itself. The marginal cost should increase for the law to hold, and the total product, the marginal product of the total product should decrease for the law to hold as you increase the application of variable factors to the fixed factor. Okay, decreasing here, increasing here. These are the two sides of the same coin. The two sides of the same coin. One way to understand the law of diminishing marginal returns is to consider that the marginal product is declining, but another way to understand the law is also to consider the fact that the marginal cost of production should keep increasing. The two sides of the same coin, I'm repeating. So we now know about the marginal costs, and they were very important in economic analysis as marginal costs, these ones. Because it's a marginal cost of your production that determine the shape of your individual supply curve. Okay, so you will now make a discovery, an important discovery in economics, that there's no need to have any special theory of a supply curve. A supply curve is your marginal cost curve. The marginal cost curve and your supply curve as an individual producer are the same curves. Okay, so the shape of your supply curve as an individual producer is determined by the shape of your marginal cost curves. You will see why shortly. Maybe let's do another example to see about that point. That is from your tutorial that you'll do on Friday. Again, same example, but instead of snowflakes, I have some abstract production process, workers employed here, output resulting from the employment of this additional workers, the total output, right? It's total output rather, right? Is that series, right, of data, and you can estimate a marginal product as a difference in the total product with associated with additional employment, and you can see it's declining, the declining marginal product. Every additional product is less and less. So yes, for that situation, the law obviously, the law of diminishing marginal returns holds without exception for every step of the way. For the entire domain here, the law of diminishing marginal product asserts itself. There are fixed for costs to the production process, no matter how many workers you're employing. It's $200 per month, we're assuming. Or is it per day? Okay, per day. Fixed costs, right? Variable costs are estimated somehow for your tutorial, right? It's just a salary for workers. We don't have raw materials, it seems, in the production. Maybe it's a service produced or work produced, so that doesn't consume any raw materials. But still, workers have to be paid for the work they do. So that's per at the rate of $100 per day, they're getting paid at that rate. And so we have variable costs associated with the salary. In the previous example with snowflakes, it was raw materials plus salary. In this case, it's just the salary that factors. Just to simplify the case and to have a very nice set of cost curves. Now I'm simplifying things here, just for the sake of having nice curves. Then I'm estimating the total cost, right, as a sum of fixed and variable. Again, I'm estimating the averages by dividing the totals by the product with which they're associated. The totals by the product with which they're associated, right? I'm getting three types of averages. I have spark lines to just get the idea of the shape of the average curves with quantity with respect to quantity, and the shape of the total cost curve with respect to quantity. Spark line for the fixed cost, these things are called spark lines. It's just a flat line, right? For the variable cost, it's increasing line, like more or less smoothly increasing. The total cost is also a smoothly increasing line, and averages are like that. They're like these lines in my example. First the increase, then the decline for all the three types of averages. And marginal costs, I told you, no matter how you calculate them, whether with respect to calculating them on the basis of variable costs, like here, right, or with respect to calculating them on the basis of total costs, like here. You take the increment the total cost, and divide by the associated increment in the product to get the marginal costs, right? One increment divided by the other increment, the increment for the costs, for the total costs, or variable costs in that instance, divided by the increment in the total output will give you the value of the cost. No matter how you calculate whether on the basis of the variable costs or on the basis of the total costs, right, you get the same reading for the marginal cost. These are the costs, right? And if you plot them on the curve or on the chart, here I have output, right, Q, and here I have the total costs, right, total and marginal costs, or as average and marginal costs on that line and total costs on that line. So for example, right, total cost is according to that value. You take that line to read the value of the total costs, increasing, obviously, like almost monotonously increasing. And averages are here, right? So this is the blue line is for what? For average total cost, declining, right? Declining like that, indeed like that. I guess because we move from 0 to 20, we can just as well cut that area. And how to cut? Well, when you're analyzing the costs, right, let me just do one thing. We don't really need to analyze the case of zero production, so we can just adjust the reference. Right, adjust the reference here. In Excel, you can adjust the reference by just clicking on the curve and adjusting. Does it work? No, it's a little bit tricky because the mouse is not working very well today. Just want to remove this jump, the original jump in the curves, because this is an artifact of zero production at the starting point. There's no real sense to this jump. The real shape of the curve starts from here, from that production volume of 20 per day. And this is just an artifact of, okay. So the real production process starts not from 0 now, but from 20, that way. Okay, this is like a typical archetypal situation for costs, this presentation. The total costs are monotonously increasing. The average fixed cost, the gray one, right? Like I said, the fixed cost is just a fixed line, but the average fixed cost is a declining line. The green one is a marginal cost, and the marginal cost, it's interesting enough, the marginal cost here is not, remember, for the law of diminishing marginal returns to hold, the total cost should increase uniformly. But here we have the production where first the marginal costs they reduce, so the law of marginal product is violated, right? Diminishing marginal product is violated because here it's not really diminishing. marginal cost decrease, so it's not diminishing product. But then, from that point onwards, beyond the output of 90, the law of diminishing marginal product asserts itself. The marginal costs keep climbing up, the law asserts itself. Okay, which is a demonstration of the law in terms of marginal costs. But I want to demonstrate something else for you. I want to show you that the marginal cost curve, that one, right, is also your individual supply curve. How? How do I know that? How can I prove to you the fact? Let's see. Let's discuss the situation of certain costs that we know about now. We know it's your production process, we know about your costs, and we are keen to analyze the marginal costs because it determines the shape of your supply curve. So we know the shape of that curve, it's given here. Now assume there's a certain price on the market holding for the output. Let's say we are producing football, right? Footballs for the market, and that's your production situation in terms of costs. What if the price of a football on the market here is $10? Okay, just to buy one football on the market, you have to pay $10 for each. All the production is sold according to the law of one price on the market. Just balls identical, they are sold for identical price, each of them. Okay, so it's the price prevailing on the market. What will your be decision regarding the output to produce per day, right? Per day on per day basis. Okay, will you produce in that domain from 0 to 20, the first 20 balls per day? Obviously, because it will cost you in terms of the marginal costs, in terms of the additional cost to produce. Each ball will be costing you in that range, the green one, right? Each additional ball will be costing you like $5 here for that range of production. Then it's even less for that range, even less for that range. Here it's like $3 cost per each. But with every sale you make $10. You sell the balls for $10, and that costing you to produce for the first 20, each will cost $5, and for every one sold in that range of output, you will make $5 profit. That difference, right, between the selling price and the cost of $5 is also a difference of $5. So every ball sold at that production domain, when you produce at that rate of under 20 balls per day, every ball sold will bring you $5 profit. So of course you will make 20 balls per day, and will increase production to 50 balls from here to here, to 50 balls per day. Yes, because the marginal costs are still below and actually declining the selling price. You will even make more profit on each ball produced in that range from 20 to 50 per day. You will be selling each for $10, but it will be costing you like $4. So it's like maybe $6 per ball for balls in that range, and so on and so forth. Will you be producing 120 balls per minute per day? Sorry. Yes, because you can increase your production because you can sell each for $10, right? And it's costing you to produce less than $5, so you will make more than $5 profit. The difference is a profit. So pretty much this area limited by the marginal cost curve and the price line prevailing on the market, that area, right, is your profit. And of course, the more you produce per day, the more profit you are making. The area is getting bigger. So you increase your production, but up to a point, because obviously at that point, here you're already costing your potential to produce balls more and more in greater quantities, right? Because here at that output of 140 balls, what's happening? Well, now the margins are getting narrower and narrower, because here you're selling the balls at that point, for example, here at $10 each, but this additional balls in that range, they're costing you already $8 to produce, not 4, not 5, but 8. So your margins are getting slimmer and slimmer and slimmer, and at that point of making 150 balls per day, the last 10 balls to produce, meaning the 140th ball, the 141st ball, the 142nd ball, and so on and so forth, 149s and 150s ball. These balls, like these 10 balls, the last 10 balls to produce in that output, they'll be costing you $10. So you'll be making zero profit on them. You will be making them for $10, just last 10 balls for that output per day. It will be costing you $10 to make, and you'll be selling them for $10. So you'll not be making, it's neither a case of a profit nor a case of a loss. So assume you are stopping your expansion here, because if you continue expanding your production to that domain here, right, beyond 150 balls per day produced, the last ones, the last 5 here from 150th ball to 155th ball, for them, you'll be spending more money on them than selling them for, right? What's the point of producing when for the extra items you are making, you end up spending more than getting from the market? You are making a loss for the additional production volume. So you will stop increasing your production volume at that point, right? You'll produce up to 150 balls per day because after that point, the marginal costs, they exceed the price on the market. Below that threshold, below that point, below 150, the marginal costs are less than the price prevailing on the market. So you increase your output. So whenever you have that situation where the marginal costs are less than the price prevailing on the market, you tend to increase your output to make additional balls. Then you reach the point of saturation for the process where the marginal costs are exactly equal to the price. That's the point of saturation in our instance, 140 balls, and you stop increasing the output anymore, because whenever, even if you try to produce beyond that, in the region where the marginal costs are higher than the price, what's the point? I mean, is there any economic rationale to do that? For an extra output, you are making beyond 150 balls when you're producing 151st ball, 152nd ball, 153rd ball. For those 3 balls, right, your marginal costs are already higher than the price. So to make those extra 3 balls, you will be incurring a loss once you sell them. What's the point? You just stop your production expansion when you make 150 balls per day, right? And beyond that, it's pointless, because any additional balls you make will generate a profit that will eat into your margins. Will generate a loss, sorry, that will eat into your margins, the negative profit, right? Those balls below that optimal production quantity will generate, each of them will generate a profit, but subsequent, beyond to the right of the optimal production quantity, each ball will generate a loss. Each extra ball will be a loss-making one. So this is like your optimal production quantity, 150 balls per day, that maximizes the profit of your production business. That's a rule, just very simple rule to maximize the profit of a business, because the profit is, as you can see, the area limited by the price on the market, and this area above the marginal cost curve, right, is your profit. The green one is a marginal cost, right? It's a green one. And that's a price that you encounter on the market, a flat line. And whenever you produce above the marginal cost, right, everything you produce creates a profit. And the profit is that area above the marginal costs and below the price on the market. That's your profit in production. So this should be maximized. That happens, the maximization happens when the marginal cost is equaling the price. The point where the marginal cost line intersects the prevailing price on the market, $10 we are assuming, right? The price is also $10. That is a point of optimal production quantity, 150 balls per day. That's how we believe businessmen are analyzing production process. Again, we make a strong assumption that everything here is continuous, even though here we have like intervals, ranges, but when I plotted them, I made them look continuous. In Excel, you can make like intervals look continuous, and that's what I made, just to give an idea of continuous curves. But in reality, of course, and even here you see that discontinuous. This is discontinuous curve. I made it look continuous on purpose because, well, economists like analyzing continuous quantities. that every changes is smooth and small and incremental and tiny, as we discussed with derivatives. Like these changes are very nice to analyze. Well, that's a rule. To maximize your profit, always make sure to produce according to that rule. Increase production up to the point where marginal cost curve is equaling your price, and not beyond, because where you have the situation in beyond, right? You'll start making a loss. What's the point making a loss? Always make a profit, not a loss. So that's why we have that rule, where marginal cost is equal to the price. And now one more thing I want to emphasize is about the shape of your individual supply curve. Again, I told you that's a marginal cost curve, right? The shape, just you can draw as equivalence between your marginal cost curve and your individual supply curve, individual S, right? As a producer, as an individual producer. Individual supply curve is your marginal cost curve, right? The individual supply curve is your marginal cost curve. Very important, because what is a supply curve? A supply curve is an association between the amount of goods you will sell at a certain price, right? So if the price on the market is like that, you claim to agree to sell that much of that many goods, right? If the price is reduced, you will sell not that much but less. So that's an association between the price and the quantity of goods that you stand ready to sell at that price. Some association, right? Some linear or maybe non-linear association, but some association. Again, this association is your supply curve by definition. The statement of how many goods you will be ready to sell at a given price is your supply curve, and that's the same thing as a marginal cost curve, because you will see shortly why. Marginal cost also shades same thing. It will tell you, suppose the price on the market is not 10 anymore but 5, right? It was 10 before, like in the previous example. Now let's make it 5. If it's 5, you will no longer be producing at the optimal quantity of 100 balls per day, right? If the price on the market reduces, and the point where the new price, this flat line, intersects your marginal cost curve will be that point. The green is the marginal cost. The market price is a flat line drawn here. If the market price is 5, I should always draw it at 5, right? And so the new intersection point is that one. Now, because the price has reduced from 10 to 5, the new optimal production quantity where the marginal costs and the prices are equalized according to the decision rule, right? You will produce up to 140 units per day. So your profit will be, in the production process, the profit that you will make per day will be that much. If you continue expanding to the former level of 150, you will be not making any profit on an additional output, you will be making a loss. What's the point making a loss? You stop maximizing your production at that point. It's optimal production point again. Your price again declines from $5 now to the new price somewhere here. The new intersection point is the output of just, is it like 100 here? I think about 100. So you again downscale, downsize your production from that level of 140 to just 40. Because what's the point making a loss on any additional output? You always want to make a profit. So your profit will be very much reduced here. See, whenever you confront the market with a certain price, what happens is you are comparing your marginal cost to the prices. And so if the price on the market is like that, you will produce like that. If the price on the market is like that, you will produce like that. If the price on the market is like $3, you will only produce 9. Was it 100? We discussed 100, much less. Not 150 anymore, but as the price reduces, your output reduces. We always read off the amount, the optimal quantity of production, right? The amount produced by intersecting the market price with the marginal cost curve. So we know that at that price you will produce that much, at that price then you will produce that much, and at that price on the market, prevailing on the market here, you will produce just that much, again according to the marginal cost, the shape of the marginal cost curve. So Does it remind you something? It's a statement about your individual supply preference, right? At that price you'll produce that much, at that price you'll produce that much, at that price you'll produce that much. The statement about your individual uh, supply preference determined on the optimal grounds of economic analysis, right? Again, this statement is called your individual supply curve, P here, Q here, right? Your supply curve, individual one. So now we see that your supply curve, by definition, according to the decision-making rule, about MC equaling to the price, according to the decision-making rule, your marginal cost curve is your supply curve identically, right? There's no difference really between your marginal cost curve and your supply curve as an individual producer, your individual supply curve, right? No distinction, no difference. The marginal cost curve is your individual supply curve. That's how we made the discovery, just by introducing to use the decision rule that you optimize your production, you increase it up to the point where the marginal cost is equal to the price on the market. It's a decision-making rule. It's not something like imposed from outside. It's how you should behave rationally as a rational economic agent. And if you behave according to that rule, to produce up to the margin meaning where you equate your marginal cost to the price on the market, prevailing price, right? Then, well, your supply curve as an individual is determined by the shape of your marginal cost curve. A very important discovery, I would say, because we know that the shape of your supply curves is now determined by the shape of your production schedules, by everything like that here. That's a statement about your supply curve. That table is also a statement about your supply curve. Implicit in that schedule is the individual's supply curve for you as a producing individual. And then maybe there's another producer on the market, right? Suppose another producer exists on the market that will produce like that, according to his marginal cost curve like that. So you have one producer, second producer, the third producer. What you do to estimate the market level supply curve? You have to adapt this curve to that curve to that curve. So you take that point at that price, you take that at that price, right? You take that point for quantity, you take it, you know the value for the second producer now, how much will produce at that price, you know the value, how much will the third producer will produce at that price, like that, right? And the second like that, right? So you will just sum up three numbers and then you will get the point on the market level supply curve. In that case, the market is made up by three producers. Maybe it will be a good exercise for you that we will do later to develop a market level supply curve from the individual marginal cost curves of individual producers. And let's say we'll have three producers like that case here. And you will sum up in Excel, of course, not by hand, but you can also do it by hand, but just summing up three numbers and depicting on the PQ plane. You can elaborate also a market level supply curve from the supply curves of individual producers being their marginal cost curves. So marginal costs are very important for us. They suggest how you behave as a supplier and how the market supply curve will look like. Because the marginal cost curves, I will be emphasizing it all the time, is your supply curve. The marginal cost curve is your supply curve. We call it S, right? Supply curve. Okay, so you should learn the trick how to develop the charts from the tables. I will teach it during the tutorial. Time to summarize some notions we discovered here, especially to summarize the shape of different curves, the shapes, right, according to spark lines. Why the shapes look like that? Especially why is that you see what happens when this is the average, which curve is it? I think it's average total cost curve, right? When you take total cost and divide by Q, you get the average total cost curve. Just generally average cost is called, I think, right? We can omit total because here we are not omitting that, but here we can omit total because it's clear that we sum up all the costs. The cost for us here is all the costs. Okay, so this is how it's looking, and then we have marginal costs, the green one, and so it's looking like that. So notice what's happening when you analyze the average costs and the marginal costs. just marginal. I told you it's pointless to emphasize. There's just one marginal cost, right? Just to prove you to use a point that there's just one marginal cost, I depicted two data series with the same values, right? The one was based on that schedule, and the other was based on that schedule, and on that schedule, right? That and that. The same numbers. So of course there's just one curve for marginal costs, and here we have a curve for average costs. See where the marginal costs cuts your average cost curve from below. It cuts the average cost curve, that one. The marginal cost curve cuts the average curve from below. At that point, the average cost curve will start increasing. Below it was declining. Where it cuts the marginal cost, and the marginal cost is higher now. The marginal cost curve will pull up your average cost curve. It's not by incidence. It's not an accident, right? Not by accident. It's a rule. It's a rule. Illustrated to you. There's a case here in your textbook by Sloan and Garrett. There's a nice case, relations between averages and marginals. Please read that box. It has a very clear illustration of the point. It says that suppose we are in a class, there's 10 students present, and the average age of all the students present is 20 years of age. And now if there's a new student entering the class, and he is older than 20, the age of the new student is more than 20 years old. So, and he is now added to the class. So the new class average will be more than 20. The fact that there's a marginal student entering the class and now constituting the class just as well, his contribution pulls up the average age of students in the group because the marginal is now older than the average. He is not 20-year-old, but he's older. So he will pull up the average age of students in the class by entering the class. And if his age is less than the average age of those present before he entered, then the average age will be pulled down because the marginal contribution is less. It dilutes the average, the old average. If the marginal is less and it contributes to the average, it will dilute the old average. If marginal quantity is more than the present average, then by entering and contributing to the new average, the marginal is higher, so the new average will be pulled up. Again, as with the age, so is with the costs. That's a good analogy in my view. See here what happens in that region where the marginal quantity is less than the existing average. Whenever you add marginal quantity to the average, and the marginal is less than the average, so you still contribute by pulling down, meaning you reduce your average by contributing marginals which are lesser than the current averages, right? By contributing marginal quantities lesser than your current averages, you are diluting, pulling down the averages. But as soon as your marginal quantities contributing to the average quantities are higher, now they're higher. The green line is above the blue one, so the marginals are higher than the averages. The contribution from the marginals will pull up the averages. There will be not a case of dilution anymore, pulling down the averages. Now the high marginals will contribute to the increase in the averages. So the marginal quantity will increase your average quantities when the marginals are above the averages. When the marginals were below, they diluted the averages. They pulled them down. Very good analogy, and that's a statement of association between the average cost curves and the marginal cost curve. The marginal cost curve, where it's less than the average, it will dilute the average, but where it becomes to be more, the higher one, right, then it will increase the new average by contributing to the existing average. So this is a good analogy. The situation that where the two curves intersect, the average and the marginal for the costs, is a situation endowed or imbued with economic meaning. Marginals will now increase, pull up the averages. Okay, what else can we do today? We can just as well summarize what we discussed, and especially with the aim of summarizing the shape of the curves, of the total, average, and marginal cost curves. I stated you the law of diminishing marginal product. Then we discuss the implications from the snowflake game. I emphasize that we play the snowflake game in the short term, not very short term, not long term, just a short term period where certain factors of production stay fixed and certain factors can be varied. We play the game in that short term, right, short term time frame analysis. Not in a very short term where all the factors are fixed, not in the long term where all the factors are variable. Not that, right? Just in the short term where some are by definition fixed and some of the production factors are variable. We analyzed the results and found that we found in that some domain of labor employed there are violations of the law of diminishing marginal product, but generally, the law is more or less upheld. The law of diminishing marginal product is such that the total product will increase, but progressively less and less. Maybe when students start treating each other on the feet, right? Not that the marginal product will decline, but even the totals will come to decline eventually because the whole process of production will be paralyzed. With students jumbling each other like we have 20 students to a narrow table. They'll start jumbling each other, right? And jostling and jumbling. So the totals even will decrease. But generally, in a milder case, you will have totals still increasing, but the subsequent increases will be progressively less and less. Initially, there'll be like an uptick in production. The marginal product will increase, but then at the point of saturation, the marginal product will start declining, and because marginal quantities contribute to the totals, the contribution will be less and less. The total product will start to flatten out. Will eventually diminish. The output from additional application of extra units of production will diminish. As we filled out the tables, analyze the shape of the cost curves, and by the way, we analyzed only the explicit economic costs. There are also implicit economic costs. Economic costs are explicit, and implicit. The implicit ones are the opportunity costs. Okay, remember from teaching Quick 1, I tried to shed certain spotlight on the implicit costs, such as opportunity costs, right? Just to give an example, so like you are a business owner and you don't pay yourself a salary, you just survive on profit, or just you hope your business will break even eventually. So you don't pay yourself salary, right? Your services to the business, is it a cost? In accounting terms, it's not, because you are owning the business, you are a business owner, right? Business, it's a business and you are owning it, right? Your business. You don't pay yourself salary, right? So it's, in accounting terms, it's not a cost of a business to pay your salary. There's no salary. But in economic sense, you contribute to your business, your time, and if you were to replace yourself with a manager, manager will insist on a salary, right? So instead of not paying yourself nothing, once you replace yourself with a manager, the manager will be compensated properly. And so implicit in your services is also a market price of compensation. Whenever you analyze your business, you should always restate your implicit costs. Maybe there's some costs which are not the accounting costs, not recorded in the accounts of a business, but still they are costs. That's a case of your management services. They cost something on the market, but you contribute them for free. But nonetheless, when you analyze your business, you have to consider that those services are not free from economic perspective. From the accounting perspective, yes, they're free, but from the economic perspective, they have the opportunity cost. In other case, okay, you are again a business owner, you contribute the plant, property, and equipment like a table or a scissor for free, right? to your business. You hope it will break even, so you're sacrificing your own personal wealth as a contribution to the business. In our case, that was a table and a scissor in the game, right? From accounting terms, right, you wouldn't pay rent yourself, right? You contributed the services for free, right? This one's for free. The table and the scissor to your business, we contributed for free, so you don't pay yourself rent. On accounting records, this rent will be invisible because you don't pay yourself rent. It was a free contribution to your own business. But when you analyze your business from the economic standpoint, yes, you contributed a productive factor, a production factor, and so there's an implicit economic rent on that factor, the opportunity cost, right? What you could have made on the market by renting that out to other third parties for money, not to yourself for free, but to other third parties for money, right? You would have gotten some returns by renting out scissors and the table on the market. Those returns as opportunity costs to your business, meaning the implicit economic costs of your business, the implicit costs, not explicit, but implicit ones. So always consider not just accounting explicit costs of running a business. Always consider some implicit costs not visible from the accounting records, but in economic sense prevailing in your business just as well. Always do that. Cost of production include explicit and implicit costs, right? So return on capital invested is an implicit cost, right? If you contribute your money to the business, that money has a cost in the form of foregone interest rate. And salary not paid to you as a manager is another case of implicit economic cost. Okay, so we have to remember that. Then we are discussing for our case of maybe game, for the snowflakes game. We have been discussing this cost, right, to the totals, the averages, and the marginal cost. And also in that simple, simplified exercise for your tutorial, same thing, the totals, the average, and one species of marginal costs, just one, because they're same. I just showed you they're the same, so there's only one species of marginal costs. We discussed that, right? We discussed that the profit is a difference between total revenue and total costs, and the aim of a business is to maximize the profit. All the decisions have to be taken strategically with that aim in view. Then we discussed, I guess, the shape, right? The shape of different costs, the fixed and variable costs. And of course, before that, we provided the definition of fixed costs. They don't depend on your output, so that's a flat line, right? And variable costs depend on your output, so it's a curve. The greater the output, the greater the cost, so it's an upward sloping curve. Variable costs are like that, fixed costs are flat, and the total cost will be sum of that flat line and the curve. So if you sum that point with that point, you will get something like that. It will be again some curve, but running at some elevation, like there will be an intercept at a high position here, according to, so each curve here will be shifted by 500 to get the total cost curve. Again, it's here, it's even here. You see, it's a total cost curve, total variable cost curve. So to get the total cost curve from the total variable cost curve, you just elevate it by the value of the total fixed cost. Sum up this green one with the blue one, you will get the red one. Okay, then we discussed the cost theory of production, that in a short term, sometimes it's called short term, no matter what, there are some fixed factors of production and variable factors of production, right? The game was based on that, right? The game has a good point to emphasize the fact that, depending on the time frame of analysis, different costs will be fixed costs, different costs will be variable costs. Again, everything hinges on the time frame of analysis. Your time frame is important to decide which costs are fixed, which costs are variable. In the long term, all costs are variable costs. You can expand your production capacity without limit. But as Keynes said, in the long run, we're all dead. So, like, what is of relevance is a shorter term analysis when only some costs are fixed costs and some costs are variable costs. Okay, so short-term analysis when the costs are fixed, some costs are, and productive factors are fixed, and some productive factors and their costs are variable, is the essence of economic analysis. We'll do that. In our game, we did that. And it is in that setting, right, that the law of diminishing marginal productivity applies. The law applies obviously in the short term of market analysis, just in the short term. This law applies not in the very short term, not in the long term. It's a law applicable to the short term of economic analysis when some factors are fixed and some factors are variable, right? Some are fixed, some are variable. That's when the law applies. That's why we play the game in the short term only. Right, so I have some slides about the short term, long run, short run. What is short run and what is long run is you cannot really pin a number on that notion. It's according to the definition when in a period in which you cannot really expand your fixed factor of production, it's still your short run. If you have allowed enough time for analysis to expand your limited fixed factors of production, then it becomes a long run. But everything depends on case-by-case basis in terms of actual time, chronological time, right? You have to be very specific, right? You cannot really convert short-term and long-term into chronological parameters, into chronological time. You cannot do that. But sometimes you can, and this conversion examples are given here on that slide. And as a good point, I think all production takes place in the short run, where the law of marginal product asserts itself, but all the planning takes place in the long run. It's a statement, it's a statement about being a visionary person in the business, right? You produce in the short run, but you have to devise your strategy for the long run. And then your business will not experience a bottleneck. That's a statement to be remembered by business visionaries. That one in the blue box. Okay, we discussed that one. Then three types of fixed costs follow, right? Total cost being the sum of fixed and variable. The averages cost, right? We take the total and divide by Q. We discussed that. Take the totals and divide by Q. Three types of totals, therefore three types of averages, but only one marginal cost, right? Only one marginal cost. We discussed that, right? And about the shapes. About the shapes, we can observe that why these cost curves have these shapes like I showed, right? Like I showed here, and also illustrated here on the slide. The rising marginal cost, it's one side of the coin, right, of the law of the total diminishing marginal product. That law states that with the additional employment of variable factors of production, their contribution will get reduced, their productivity contribution, the productivity will be less and less for every successive factor employed. And therefore, the marginal cost curve will be increasing, right? So the marginal cost curve is increasing because of the assertion of the law of the diminishing marginal product. Rising marginal cost curve, increasing marginal cost curve is just a statement of the law of the diminishing marginal product. Average fixed cost curve always declines, right? Because the total, the total fixed cost, right, just fixed cost itself, right, is a fixed no matter what the output, but then you spread out that value of a fixed cost over progressively greater output. So your average fixed cost curve will indeed decline. Average variable cost will typically increase. We're discussing average, so it will have an extreme point, some extreme point, right? Average variable cost has some extreme point, and remember that thing when the marginal cost curve intersects the average, the marginals intersect the averages are pulled up. Before that, they're diluted, the averages are diluted, where the marginals are less than averages, the averages are diluted. But then, as marginals come to dominate and are higher than the averages are pulled up. Again, we observe that, right? And so averages, they have certain hump here, certain extreme point, which is optimal point of production. average fixed cost first declines and then increases. So it should have a hump. The average total production cost is minimized, ATC, right? Again, the location of that hump on the output axis is determined by that intersection point with the marginal costs. This is the emphasis on that point. I guess that slide just shows you that where the marginal costs are less than the average total costs, the average total costs will still keep declining. But where they intersected from below by the marginal cost, they will start increasing. Again, stating the same fact. This analogy I showed you for the age of students in a class, right? That helps you understand that logic about the association between the average costs and marginal costs. Where they intersect, the averages come to increase. This is a good analogy. Please read that book. In Sloman and Garrett, you will have that box 5.3. Pay attention to that. And then I think the last thing I did for you was to introduce that idea that the marginal cost curve is the individual supply curve by definition. Because of the decision-making rule, you optimize your production up until the point where the marginal costs are equaling the price. Up until the point, right, you increase production and not beyond, so you stop increasing your production at that point where if there's some price, right, on the market, $5 on the market, then you just will increase your production according to your marginal cost curve. You will increase your production up to 80 units of the product. Only up to that, not more, because you'll start incurring the loss, eating your profits. And below, it will be suboptimal to operate in short term because you can still increase up to the optimal point to increase the profit, right? The profit is the area above the marginal cost curve and below the price. The profit is that area. And it's maximized at that point where the price intersects the marginal cost curve, giving you the optimal production quantity, right? So this is a law of marginal costs. The marginal cost curve is a supply curve for you as an individual supplier. S curve in terms of P and Q, your S curve, right? Remember the upward sloping S curve, the downward sloping demand curve. That curve is your marginal cost curve by definition, almost by definition. Okay, very important. And your homework, we are done. Please read chapter 5 from Sloman and Garrett, the supply decision. Please, I'm beseeching you to read auxiliary reading from Heilbronner. You have to read that book. To understand anything about economics, I don't think you can understand anything. That's not enough for sure. It's very theoretical thing. It wouldn't inspire you to study economics. But economics has social and personal dimensions. I think this book brings them out in full view. A very important text to read. Please read that one. Heilbronner, you have it in the top of the Telegram channel. And Simon and Bloom is to catch up on math. Please continue reading that. As far as the derivatives are concerned, it's chapter 2, I think, right? Also in top of the Telegram channel, we have it. I guess we are done with the class. Thank you for your attention. The summary is provided on the last slide. We have the summary of all the types of costs with the formulas. I think also helpful one. We are done with the class. Thank you.